Hello, everyone, and welcome to Cisco Unplugged. My name is Dan Klamert, your host, and I'm back here again with Al Dumdei. How are you doing today, Al?
Good, good. You look like you've changed offices again.
Yeah, I'm on the move here out
Good.
in San Jose.
All right.
Nice, nice. Yesterday I was in San Francisco. It was a little cool, there being on the bay, but today it's going to be a warm one here. So nice.
Nice.
So not that I'll know. It's always the same.
It's all the same inside.
Rooms, yeah.
Yeah.
For sure. So this week on episode 65, we're going to be discussing how ultra reliable wireless backhaul is coming to the Catalyst 9800 series controller. And very excited to talk a little bit more about that in depth. So I'd like to welcome back to the show Igor Moisev and Ian Prosek. How are you guys doing today?
Doing well. Looking forward to jumping in with you.
Yeah.
Same here, Dan.
A couple of guys with just a wee bit of experience in this world.
Exactly.
Yeah. Actually, I forget the episode, but Igor, you've been on once or twice before. I think that's a while back. We were talking about some URWB stuff. So, and if you go way back in the archives, I think some of the very first episodes, we were covering a lot of the URWB things under the guise of IoT, just in general, right? IoT connectivity. So, cool.
Yeah. I was going to look up those numbers and I forgot. So those episode numbers, but a quick search on our YouTube channel, of course, will pull those up. But speaking of the YouTube channel, this is streaming live on YouTube, and we do record these for later viewing. So the YouTube channel is youtube.com/@getunplug, and you can go out there, like, subscribe. And if you click on the bell to be notified, you'll be notified when we do post and go live with other great content like this. So we do also take questions via Slido as usual, and sometimes via the YouTube chat too, if you're anti-Slido, but either way works. But the Slido way to join that is up there on the screen, and also via the link below the YouTube video. And also while you're on the YouTube page, our landing page, you can see upcoming episodes. So we do have an upcoming schedule there posted now. It's under the links section, under the title bar of the page. It's the next couple episodes or a few episodes, depending on how far out we're booked, and got things locked in. So it's a good way to plan ahead. Of course, there's things that are subject to change, but appreciate you guys liking, subscribing, and turning on that notification bell so you are notified when we do go live with these episodes anyway. So I think that's it for the reminders. If you have questions, submit them. We'll try to get those answered like we usually do during the episode, but let's get unplugged here. So Ian, do you want to talk a little bit more about URWB?
Sure thing. Absolutely. And, this is a little bit of a rip from some of the presentations that we did at Cisco Live this summer, plus some test data and things we've been showing or going to show you. So if you really want to go into the whole meal deal, there's a session called BRKEWN 2049, I think is the number. And you can search for Dave Banham or myself, and you'll find it that way too. We did a session on outdoor wireless in general. And of course, like the Oreo cookie, URWB was in the middle of the best part. So that being the case, this is the first time I think we've talked about. We showed at Cisco Live, I think we had a video interview with DJ from the booth on the show floor. We showed, what the initial setup was going to look like. We're going to go just a little bit deeper, show you some screenshots and some configuration here today. And like I said, some demos as well. So the very first question, what we want to address is, why? And so the thing here that we need to consider is where we've been. And if anybody's configured worker bridges and devices like that in the past, you understand just, what that involves, right? We're doing box-by-box configuration where we are managing devices individually. If you need to change your pre-shared key on something, that is individual configuration. That's time-consuming. You need to adjust roaming profiles, those types of things, or roaming settings rather on a device. Those are all things you do one by one. You can script some of that, but basically what we're trying to do is provide centralized management and monitoring of mobile endpoints that are connected by URWB. And of course,
Like we've done this before with the controller.
This is very true. Yeah, absolutely. Like when you think about the CapWeb, right? And that's actually what we're doing here is we have a CapWeb, control connection running to administer the device basically. There's some overlap here with some of the things, of course, with WGB and with Mesh. We'll talk about that a little bit later on. So I think it's pretty self-explanatory. You understand what we're trying to do here. And so when you take a look at URWB overall, and Igor, feel free to jump in here because this is equally your game. This is a combination of technologies that we acquired a number of years ago with Fluid Mesh that provide a higher level of resilience and connectivity to the device. So ahead of things like perhaps Wi-Fi 8, which likely will bring MLO at some point in time down the road, we've had the capability of multipath operation for a number of years with URWB, proprietary that be the case, and the ability to have seamless session mobility across multiple uplinks at the same time. So things like that, and, at high speeds. I don't know, Igor, what the highest speed you've ever seen in roaming, but I mean, certainly any vehicular type speeds, I'm assuming.
Yeah. I mean, I've heard of and seen speeds up to 250, 300 miles an hour. Think of those maglev high-speed rail connections in Europe and Asia. As long as you have line of sight and spectrum and a clear handoff to that vehicle, anything is possible. But generally speaking, AGVs, they travel a couple of feet per second. Container handlers, large mining dozer vehicles running at safe operational speed, let's call it 20, 30 miles an hour. So it kind of varies in terms of that mobility velocity.
Yeah, absolutely. So, when we think about how we've been deploying URWB in the past, this is the main tagline here, which is you've been deploying typically these networks independent and parallel of your existing Wi-Fi deployment. And there's time and a place for that. We're not going to get away from that. We're going to allow you to continue operating equipment independently. Let's say you've got a point-to-point shot out in the field somewhere that's all you ever need and all you ever want. There's no sense in necessarily complicating that and adding extra things. But in the vast majority of deployments where you've got, a warehouse, for example, well, you probably also need Wi-Fi to service, various devices on the warehouse. Maybe your forklifts could be benefited by using URWB or things that are mobile AGV, stuff like that. Now we can converge this into one network. We can actually do this all on one infrastructure. And we do that by actually operating this on a per radio slot basis. So we have the ability now to do this without actually having to have two different, images running and, some APs using the URWB, some using Wi-Fi. So that's really what we bring in 17.18.1, and the ability to have a unified boot image on the AP that allows us to select which radio slot on that access point, except for 2.4. It's not happening on 2.4. This is 5 and 6 gig only. We can select which radio slot we want to use to do our backhaul operations on, and away we go, right? And this is all managed by the WLC, like I've been saying. So this is just a visual of that. Again, no separate mode is also required. So you can do this on, local mode or flex on an existing CapWAP AP, which is kind of cool. So I think that's the biggest, piece here, going from a 2-box solution to a 1-box solution. So when we look at the actual data path and the data flow here, just to get your head around this, this may be review for some, but this is what we're looking at here. So we've got, Catalyst Center, and that will eventually become the management point for the solution as well. It's still a work in progress. 9800 UI is where things start in 17.18.1. We're all familiar with CapWAP, right? That's been doing that for 20 plus years. So that's the CapWAP tunnel from the AP to the controller for existing Wi-Fi traffic. When we introduce, for example, an IW9167 here that is running in URWB capability, we can do that URWB backhaul to that existing AP that we would call a coordinator. We need to have one coordinator in the system for handling roaming. Today, that function is sitting on an access point, showing a 9178 here. But that Wi-Fi traffic from that device, in this particular case, you see a camera here, is actually standard CapWAP traveling inside of that URWB uplink, right? So, you could think of this like CapWAP over Ethernet bridge and mesh, would be an analogy here, except now instead of using Ethernet bridging and mesh, we're using URWB for that backhaul operation. So that traffic exits the URWB coordinator, drops out and goes back to the WLC as we did normally expect, right? So that's pretty typical. If we build this out a little bit further and we look at an example here where we've got a device that is speaking non-Wi-Fi, right? So this would be, like say, an AGV. right? So you might have something that's robotics, high-speed mobility in your environment that probably will not have Wi-Fi per se. It'll just have a URWB uplink, but we still need to have control channel, right? So we have a CapWAP control channel on 5246 going back to the WLC, so we could still see the stats and administer that endpoint, right? That's still a function there. So kind of putting this all together, you can see what we're doing here, right? We're keeping that L2 domain, much like Ethernet bridge and mesh. If I have traffic flowing over my mesh network, it exits at the root AV. In this case, it exits at the URWB coordinator, right? And it has to be all the same L2 segment here. And for my CapWAP traffic, whether it be tunnel to the WLC or Flex Connect, that's up to you. But if you're going to do that, you have the ability to pull in all that back to WLC, so your wireless clients can roam like they've always done, and that's kind of cool. So I thought I'd just pause there and maybe see if there's any questions or comments on kind of the architecture. I see Al here about to say something.
Quick question of the previous slide. I'm in the kitchen. I realized I was on mute. I apologize. The 5 and 6 gig. So are there limitations on 6 gig here? Can I just take this outdoors and run 6 gig? I mean, what else do we need to worry about from a 6 gig standpoint?
Yeah, so right now, this is LPI only on 6 gig. So we haven't gone through the certification process to do SP. There's a number of complicating factors you can imagine with chicken and egg scenarios, or I'm trying to bring up a backhaul link before I've got comms. How do I do my ASC check-in if I don't have comms, right? And so there's some of that has to be worked through. Different ways of solving that problem. But for now, LPI is the way to go. So that contains this to indoor deployments. If you're going to do it on 6 gig, of course, 5 gigs has no such requirement. We can do just like we've been doing mesh for years and existing URWB on 5 gig. We can do that all day long, indoor or outdoor on that band.
Gotcha.
Okay, good. Cool. Okay, so considerations, right? And that's actually one that Al brought up here. The next thing we need to think about is, the access points that we're supporting this in. This is something we covered at the session at Cisco Live. I mentioned here subject to change. I'm literally plagiarizing this right from our slide deck that we delivered. So even though this is out, I don't know how much is subject to change at this point, but this is where we sit right now, and you just keep an eye on the release notes. We don't want to get in front of PM here on the channel. So this is as it is. So we're going all the way back to Wi-Fi 6 APs. In fact, you'll see in the demos here, I've got some 9124 that I jury-rigged up to do some of my testing on, which is kind of cool. You think about that. That's a 2018, 2019 product where we're delivering some really cool functionality on. More typically, you're going to see things like the 9167, 9165. I know, Igor, you've got some of those in your setup. And of course, our 9178, 1076, our indoor product, which you typically find in a warehouse application, things like that. So that's where we're at right now. I also wanted to call attention to a document that got published here. It's a technical reference. You can Google search this or try to find the URL at the bottom of the screen. And this just kind of goes through the formally tested and supported use cases right now. In this version of code, and we made this very clear to people coming to our Cisco Live presentation this summer, this is still in alpha or beta, depending on the product that you're using. So I wouldn't necessarily advocate for this for primetime deployments right now in the .1 release. There's certainly some things that we've seen in our testing here that you got to work around or refresh to bring up the UI. That'll get cleaned up over time, right? But .1 release here, get your familiarity of how this is configured and how to deploy it. Just be aware of that guidance. Also, the countries that you're operating in. I believe there's some recertification that has to happen to support URWB mode in the different countries as well. And so you actually see a table that is, I've kind of divided it into two here that talks about the country codes as well. So just keep in mind. Also, layer 3 architectures in this release are not supported. So if you're going to be doing mobility, you got to be in the same L2 domain. If you've come from a world of AWPP mesh in the past, that's not a new concept. If you're moving things in a mesh, they all have to be in the same L2 domain for Ethernet bridging. Al, you brought up the point 2 already, right? Which is AFC and outdoor is not a thing yet, LPI. We're going to be on 5 gigs, 2 or less radios on 5 gigs, or 6 LPI if you've got that available. No SDA support, et cetera, et cetera. You can reach as well as I can. So with that, I thought it might be worthwhile to spend a bit of time going into just some of the configuration UI and what that looks like. So one of the cool things that we've done here in 17.18.1 is, and you might have seen this before if you're familiar with the 9800 WLC, we have this thing called WalkMe, which is like an online, if you're cloud connected in your WLC and has reachability to the internet, it will actually do a walkthrough for you as you go through the UI for the first time you're setting this up. So it will actually literally do like Clippy kind of style guidance around, go here, click here, do this. And so this is literally, yeah, I know. It'll come back, man. The agentic AI will take over as we'll have Clippy version 2. Exactly. One day you'll just be able to whisper into your WLC and just say invoke URWB, and it'll be like talking to tricorder or something, and it'll just happen, right? So anyways, there's this UI walkthrough.
Doesn't say, I'm sorry, Ian, I cannot do that for you.
Yeah, HAL 9000 comes out. So you could do that, but just to kind of put yourself in the headspace. And, I started playing with this last week myself. I watched some stuff at Cisco Live and actually got my hands on shipping, production code with my old APs here, my working museum, and started hammering on this and had to get my head around how this is all being configured, right? So the big takeaway here is when you look at the way the config model is set up in the 9800, we're familiar with the existing RF tag, site tag, policy tag. Nothing's changing at those three levels. What we are introducing is this concept of a URWB network profile, which nests under the radio profile. So you can configure the channel settings and some of the network security keys and radio roles in this new profile that is configured. And that's where this is set up in the UI. Ignore the build version here in this. This is now this is like an early engineering release. 17.18.1, you'll see this in the same spot. You got to make sure. My first problem was I didn't actually have URWB enabled. So I was beating my head against the wall trying to figure out why this wasn't working. And I'm like, what is going on with my setup? And I'm pinging Igor. I'm like, Igor, man, my stuff isn't working. And then I'm like, oh my God, is it turned on? So no, it's not turned on. So I had to go make sure that was, I didn't obviously follow the whole WalkMe. So it's typical guy thing, right? Don't read the manual until the very end. So once you got the...
fun reading the manual. Come on. Yeah.
Totally.
My wife was just yelling at me this weekend for that. It's like, come on.
It's the best way to learn, right? Just bump into things until your head is so hard that you gotta approach it a different way.
Exactly.
So under the radio profile, we also need to configure the URWB settings as well. So this is where you're going to select your radio role, whether you're point to multi-point, relay, that kind of thing, the band you're operating in. It's important to note that at this point in time, URWB, just like it was before it came to the 9800, is static channel allocation. So you got to pick your channel you're going to deploy this on. That's something that I think we'll look at down the road with things like RRM and whatnot. But that's something you need to set up here. And then if you're, some options of doing point to multi-point as far as scanning and whatnot as well. So once you got that dialed in, you go back to your RF tag, and then you can say, okay, well, I'm going to put my URWB profile in here. And then you can pick which radio slots you want to put that profile on. Right. And typically it's going to be at least one radio slot on the AP. And for me, in my testing, I just picked the second slot on the 9124, which is ports 5 and 6, and away I went. And this is just what the UI looks like here. So in real time, just a visual of what that is. I'm just scrolling in here, taking a look at my test profile. And under mobility, you can see the different configuration options you have here. I'll full screen this so you can see it better. MPO, multipath operations. If you're going to actually do packet duplication, I know Igor in your lab, you were experimenting with this. I certainly wasn't in my very first kick at this, so we'll get you to talk a little bit about how that plays. And then there's your ether types, which is kind of cool. If you want to configure non-standard ether types, which is something you can't do in traditional mesh, right? And in the world of IoT and industrial networking, that's pretty important. So here we go into the RF and radio section. I've got a 2 spatial stream profile set up because I wanted to only have 2 antennas running in ports 5 and 6 on my 9124. And there's your options here. I'm just using fixed at this particular point for my testing. On channel 165, just because my neighbors haven't completely obliterated that channel yet. And I'm just using the fixed key here. So I think I hit update and apply, or I canceled out of this. And so once you got that all done, then the next thing is to go in and associate that to the RF tag, right? So when we go into the RF tag, you'll see here, I've got an RF tag created, which calls on that profile, and it calls on the 2 spatial stream configuration. And I did this also because I got a limited number of antennas I can play with. So I just did 2 SS across the board, just setting that up. Of course, you may do something slightly different depending on how things go. So that is how that worked. So I'm going to just stop there. I don't know if you had any questions at all coming yet, because they're kind of rapid fire here.
Yeah, maybe just at a, and you kind of covered the topology a little bit, but just kind of a use case, right? So
Sure.
The use case would be, for example, maybe I want to have a remote coverage someplace. I could have these 2 URWB APs running URWB on the, say, 6 gigahertz, and then offer 2.4 and 5 for service off of that second URWB access point, cable access point. So if I had a 9178, for example, in a couple of 9178s indoors, I could effectively use it to, almost like we did with mesh, to extend coverage. Is that fair?
Yeah, Igor, you want to take a shot at that one?
Yeah. I mean, to me, the common use cases are kind of fixed backhaul. So think of your point-to-point, point-to-multipoint deployments. You have a static RF, more or less a set and forget from an antenna placement perspective. And that's going to handle
an Ethernet in that case. Ethernet into the radio effectively, and then something else on the backside.
Yeah. So think of Curb as a Ethernet extension over wireless. So instead of trenching fiber or a CAD6 cable, we're just going to shift to wireless and beam that signal either directly to another client. So that could be a point-to-point architecture, or it could be one-to-many. So if you have a sector antenna on a building edge, talking to multiple light poles with cameras, with access points, with VoIP, ETEL, that would be a common use case we see in a lot of industries. So all of that's going to be covered under that fixed role that Ian kind of looked at the drop down. Then if you want something more complicated, point to multipoint with the mixed architecture off one of the radios, that's where you kind of want to click that point to multipoint, that fluid max configuration for those more complicated multi-hop architectures. And then last but not least, mobility. So if your client is a moving vehicle, so it could be an AGV, it could be a train on a track, it could be a utility yard dog at a port or a mining facility, or it could be a 45-foot high Caterpillar dozer or something in an open pit mine. Something that you want to hand off and also seamlessly hand off so that you can backhaul those mission critical, latency sensitive PLCs, for example, or in some cases, cameras as well, if you want to do, say, teleremote of that vehicle from a safe location.
Quick question on the 5. So a lot of times we have radios like 9178. You can do dual 5, right? So when we think of URWB on a radio, does that mean URWB has to be on 5 gigahertz and I don't have any other, I can't use the other 5 gigahertz slot for client traffic? Or does that mean they're treated completely independently? Is it per slot or per radio that we're doing URWB? Maybe that's a good way to ask the question.
Yeah. I'll see if I can bring up the slide here, just kind of bring that back up, but it is per slide, right?
Okay.
Let me just get back to that here and I'll see if I can bring it up on the, so let's do this here. So
there, if you let slot 1 and slot 2. Yeah.
Exactly. Right. And that's what I did in my demo, which we'll get to in a minute here, is we actually had backhaul on, slot 2 of the 9124. I put the AP out in my front yard on my battery pack and backhauled it into the house. But I also wanted to run my testing on 5 gigs. And so my Wi-Fi client was going to hit on 5 gigs on the other slot 1, right? The first slot, ports 3 and 4, and then 9124. Separated the antennas apart. So that's what I did in my setup. So
can I use just 5 gigahertz and then offer service? So in this case, 5 gigahertz would be my backhaul, but then I would have client service on 2.45 and then 6. Is that an option?
Yeah. If you have, if you're doing this in a scenario where you've got 6 gig LPI, for example, I would imagine that wouldn't be a problem.
Yeah.
Okay, let's jump with the standard connection network.
AP that has the 4 slots, right? So
Yeah, exactly. Sorry, Igor, you're going to say something?
Yeah, like for example, this 9178i, it's a quad radio, so we can kind of mix and match the profiles we want to apply. But if you're looking, say, a 9165E, we only have 2 radio slots here, and it's a 5 and a 5.6. And if you look behind me, there's a 9167E, so that's a tri-radio, 2.4, 5, and a 5.6. So it gives you a lot of options to kind of mix and match. Hey, let's put curb backhaul on slot 1 and maybe do 6 gigahertz Wi-Fi on slot 2. Or in that use case with the 9178i, that's great for manufacturing customers, hospitals that want to upgrade to Wi-Fi 7, have Wi-Fi client access on 2.4, 5, and 6, but then also have mission-critical URWB mobility connectivity to that AGV or that mobile workstation if you're at a hospital. So it gives you a couple extra tools to work with in your tool belt.
nice. Thank you.
Okay, Igor, I know you got a couple of things here you wanted to go through the demos on. I know I'll just advance it along here and feel free to.
Yeah. Can you just go back up one slide? I'll just kind of talk through.
Sure, yeah, absolutely. Let me put this full screen for everybody here. Go ahead.
Yeah, so starting with 17.18.1, we can configure curb, and you can also monitor curb through the controller. So if you go to the monitoring wireless URWB monitoring section, this looks pretty similar to what we're used to with Quadro, which is on device, and IW Monitor, which is that Docker application. So now this is kind of a different view directly from the controller that shows you the architecture. So in my example here, it's going to be a 3 radio network running mobility. It's going to be a single channel, no MPOs being run. That's kind of a more advanced config I want to try later on. But you can see the wired connectivity stats, the coordinator. So for example, there's one coordinator like Ian mentioned, and that would be kind of synonymous to the mesh end role that we used to set on FM and IW radios prior to this release. And then we're extending that coverage wired, which is what that black line is indicating, to another access point. So in this example, we have 2 base radios. So base means it's tied to your infrastructure. And then that blue link is your wireless connection to the client. So that's your roaming client that's going to roam seamlessly as long as you have coverage from your base APs. Okay. So yeah, there's been a couple of rainy days the last couple of weeks, so I did a couple of indoor mobility tests. So I had to get creative with how to stretch the RF and also have it internet connected. So my setup here at home is tied into a Netgear router, so running on Cox cable internet, DOCSIS 3. And then I have a Intel NUC running the 9800CL, so the virtual appliance of that controller on ESXi 7.0. And then from there, I'm networking the Netgear to those 2 base APs. So I have one on the second floor, and then I have a long Ethernet cable going down to the first floor. And you can kind of see, this isn't exactly my house, but you can kind of see where the RF handoff happens. And it's more or less where you lose line of sight. And that's kind of a good rule of thumb when you're kind of going out and doing site surveys, understanding the RF placement, and also kind of eyeballing the roam area. So in this case, it's a wall partition, and I go from left to right, and I immediately hand off to that first floor AP. And then you can see a couple of the examples on the left-hand side with that wired AP, and then also that disconnected client connected to a Venvolt PoE++ battery pack. So I was just carefully walking up and down, doing a ping test to that default gateway, and showing seamless handoff as I'm going from level 2 to the floor level at my house here. So here's kind of the network architecture. So you saw the physical layout there. Here's how it's configured from a network standpoint. So we have the NUC directly connected to Netgear, which is also serving as the gateway to the internet. That's going to be on .1. So that's going to be the IP address I'm pinging from that OT field laptop on that vehicle. And then I also have those 2 base APs that are providing coverage to that mobile vehicle. So in my case, just a
AP on a stick, a speaker stand, just to show the handoff and connectivity. So today we're going to focus on the red connection here. And then I also have Wi-Fi running on the 9167. So that's just standard cap WAP Wi-Fi there. And before we kind of dive in, so like Ian said, we are in a beta mode. So you are going to see a couple of things that we are working with engineering to identify and hopefully fix by that .2 release. In particular, just kind of give you a heads up, the throughput stats you see on the left and right hand side, you're going to see some ridiculous number, like 1,000, 2,000 megabits. And that's something that we need to take back to engineering. I'm assuming that's data rate or suggested rate. And then also during the handoff, with Quadro, with Monitor on the previous versions, it would switch. Whereas here I have to toggle from one link to the other. And you'll see me pause for a quick second during the demo. Awesome. Okay. So here's my setup here. So you can see here the coordinator. You can click on that. You see the active role. You see the host name, the mesh ID, all that stuff we're used to seeing. And then the second AP. So it's considered a backbone. And then your client. This is your wireless client that's going to roam seamlessly between these two APs. And if you click on the blue link, you can see some RF stats. So this is the secondary link. And this is the primary link. So we're at neg 40 on the primary link, neg 60 on the other. And now I'm going to start a ping test. So this is a 200 millisecond ping test, that default gateway. And take a look at the RSSI starting to decrease, and eventually we'll get to that handoff spot, which in my setup was around neg 60, neg 65. But you can see end-to-end network latency, less than 10 milliseconds. These are all default settings, by the way, too. And now we've come to the handoff spot. So we're not pushing data on that primary link. We've handed off to that secondary link at a better signal strength. But the ping is running in the background, so showing you that seamless connectivity there. So this is me walking closer to the AP, and when I'm right next to it, you probably saw a neg 32 dBm, so a very hot signal from an RF standpoint. And then we're going back the other route, so going closer to the staircase. And once we approach neg 50, neg 60, that's when you'll see that handoff decision being made to the next AP. So just give it a few more seconds. Okay, so we're getting to that handoff spot here. Okay, neg 60. Okay, now you saw the throughput kind of disappear. So now I'm toggling the now primary link to that AP on the second floor. And this is me walking up the stairs and getting higher in signal strength until I eventually stop in the testing. But you can see the ping traffic on the right-hand side. I mean, you get a couple blips here and there, but no ping loss so far. And we'll see a nice summary at the end of this demo here. So 500 packets transmitted, 0% packet loss, and an average of about 9.5 milliseconds. So pretty good latency end-to-end, no disconnects. So for those mission-critical applications where you have to transmit PLC traffic and transmit it very often, this would be a great technology to backcall those types of use cases. But yeah, just wanted to show that to you guys. And I've done this demo about 3 times. So I've started off doing it with FM and Racer, then eventually IWs and IoT-OD, and third time's a charm. So now doing it on the controller and showing you that seamless handoff from an architecture standpoint.
I keep having flashbacks to some of my warehouse customers that have like really finicky AS400 terminal emulation going on. And, it's like any packet loss at all is completely a killer, right? And we've tried over the years to dial in WGD roaming settings and constrict the channel roams and our channel plan, just a couple channels to speed up the scan times. And yeah, this is bringing back some memories for sure. So that's cool.
Yeah, these are default settings too, so no real fine-tuning. But for those more advanced configs with multiple frequency, fluidity, and MPO, that's where you need a kind of second set of eyes and a deeper dive into the configs.
Right on.
We have some questions here if now's a good time.
Sure. Yeah, let me just pause this for a second. Go ahead.
Sorry, I don't want to interrupt the demo, but
No, it's okay.
Does a coordinator need to be a dedicated AP, or can it also be a bridging AP? And is a coordinator needed for simple point-to-point bridging?
So short answer, yes, you'll need a coordinator to more or less create and set up those LSPs. So label switch paths between the coordinator and all of those clients. So the base and also the client out in the field. And it could either be a dedicated hardware appliance with the radios turned off, or it could be an active radio. Just really depends on the throughput and the client density you're trying to handle. So if you want to do double duty and stretch that RAM and hard drive of the AP, then you can run those at the same time.
What about, just adding on to that question, what about redundancy with the coordinator? Is that?
Yeah. So I haven't played around with it firsthand, but similar to the Titan or the high availability configurations we had with the FM and IW radios, you can create a virtual coordinator pair. So kind of like an HA VRRP type setup. So you have two physical IPs, one virtual, and then if the physical device goes down, you still have a reachable virtual IP.
Gotcha. Good. Thank you.
A couple more here. As far as with Curb and Wi-Fi, can they coexist? Can Curb coexist with the existing Wi-Fi network? I think it can here, but specifically more so, the question is, can they be on the same channels or should they be separate? If separate, does Curb automatically avoid Wi-Fi or vice versa?
That's a great question. So as Ian mentioned a few minutes ago, the RF configs, the channel settings, and the channel bandwidth is a static config right now. Okay. Whereas you have RRM and DCA running on the Wi-Fi portion.
Sure.
My best practice is you don't want overlapping channels. You don't want the same channel for Wi-Fi and Curb.
Sure.
But also be cognizant about what channels you're using. And if you're using, say, channel 48, maybe exclude that channel from your DCA list. So that way the Wi-Fi can coexist with Curb and it could switch to a unoccupied channel if needed to.
That makes sense. Thanks.
I'll also just make a note that when Dave and I were preparing for our Cisco Live session this summer, we tested engineering a little bit to get a handle on energy detect behavior and carrier sense and whatnot. And the chipset is underlying, of course, a Wi-Fi chipset. And we got confirmation that there's been no change in the URWB mode to energy detect threshold. So as far as co-channel and things like that, I mean, obviously you're going to try and do your best design, but you're always going to be somebody else's network probably within your shot, right? So how does that play, right? It's not like it's just a fixed transmitter that's sitting on the frequency occupying and that's it. Right, it still does energy detect, right? So proper planning is still a big thing to do. Although the spectrum analyzer every once in a while.
I got to see what this little toy truck's going to do here.
Okay, so yeah, the toy truck. So it's actually
size truck with a real large access point.
That's right.
Right. Yeah, you're right. I didn't see the scale. I should have.
I could run it and grab it right now, but this thing actually, it's about that big.
Oh,
so it's sizable. It's a 1/10 scale. So I bought this thing for doing the testing like this because I thought, that's kind of cool. More toys.
Exactly.
Plus, it's a really cool
mobile control, or what is this?
Oh yeah, absolutely. I got the remote right here, so you can. I was debating whether or not we're going to have it fired up during the episode here, but I did this last night actually. So here's the deal, right? This little FJ40. I used to have a Land Cruiser, so this is why I kind of like memorabilia here. Mine was 10. 1981 BJ42 as it was called. Anyway, so I put the 9124 on this thing initially, and this is like way overweight, right? It's really top heavy because I got the 9124. I didn't even have a DC power supply, so I ended up using a little an AC inverter and a battery. So there's like 10 pounds on this thing. So it wasn't too happy. We flipped over. So I even had to beef up the suspension there and leave the shim underneath. Otherwise, it would bottom out. So you know what? Okay, I'm going to strip this thing down a little bit. I did run my testing with URWB and put the 9124 on the roof and drove around and whatnot. But inside this truck, I got my little webcam, which is an InstaLink 360 webcam. And I put a little mini PC, a Minix, a Z300, it runs off 12 volts. So I can use my camera batteries, my 12 volt battery, V-mount battery to power this thing up and literally have a mobile WebEx device inside here, right? And so my second round of testing, I'll show you how that went. So, and the really cool part about this vehicle is that the steering wheel is actually articulated.
Oh,
that's awesome.
So I'm remotely controlling my RC here. I think, yeah, and this is a good excuse for not doing the weeds in my backyard.
It's even got that sound.
yeah.
Yeah, straight cut gears. Like a Ferrari.
Does that whistle wiper work?
No, I can't give you that much down.
The speedometer works, though.
If you watch closely, you'll see the steering wheel move here in a second as I veer to the left. So I have two access points. I have one in the backyard. And now this device is actually, you'll see here on my trailer, you'll see it in a minute, but on that trailer on the left-hand side, I've got an AP, a 9124 set up as a repeater. It's basically using URWB backhaul. And I'm doing all this testing now on just straight up Wi-Fi. So I'm handing off between two APs, doing this live video over WebEx that I recorded.
You didn't run into any dogs chasing you or anything, did you?
No, but I had some neighbors asking what the hell's going on because this thing's driving around remotely. There's nobody visible. Like, I'm inside my house. I'm watching this over a computer. So here I see I turn around. I'm looking out the side window now. And there's the access point, right? So I got a directional. I borrowed a patch antenna from the 9163 as my backhaul antenna. I've got that hooked onto ports 5 and 6 of the 9124. And then I've got a couple Omnis on the other ports there for 5 and 6 gig, 5 and 2.4 access on the 9124. And there's my battery pack laying on the fender. So the whole thing is just sitting there running off a battery on the trailer. And then I got a little bit too comfortable in my attempts to off-road this thing here, and you'll see what happens.
No.
I'm like, sweet, there's a rock. Let's try it out.
Oh. Oh no. Crash and burn.
Yeah, so that was a fun time. Anyways, there you go. There's your FJ40 demo. So, we're kind of summing this all up here, I guess. And this is, adult one release, right? So, start playing with it like we're doing, having fun here, and get familiar with it, because I certainly think this is going to help us out long term with some of the challenges we had over the years with things like worker bridge administration and whatnot, especially at scale, improving our roaming capabilities. We can obviously now do this on this AP at the same time, right? All the way back to Wi-Fi 6 APs like the 9124 I was showing you here, 9130 as well, same chipset. Flex and local was supported, and I don't know if you want to add anything else there, Igor, as far as points around use cases and whatnot. But I think when customers look at this, and worker bridge comes to mind, what we're doing with mesh over the years, we kind of got to an apex in mesh in like 17-15 era, and we haven't been doing mesh on any of our Stix-E products since, right? And even WGB for that matter has been kind of spotty. So this kind of breathes some life into our portfolio again on as far as wireless backhaul. So those are some of my closing thoughts here, just kind of top of mind.
Just so that everybody knows, Wi-Fi and Curb are not the same. There's a lot of similarities, but I cannot take a Wi-Fi client and connect it to a Curb radio or vice versa. Correct?
Absolutely, yeah, and even packet captures there. I don't know, Igor, you're going to say something?
Oh no, just agreeing. Yeah, they are two separate kind of technologies.
Yeah, absolutely. So the back layers being the key thing that's a differentiator there. So there's obviously some secret sauce to how we're doing all this, and time will tell whether or not standards get caught up to this point. But the nice part about all these things, just like they were in Workgroup Bridge, was you can go in and configure parameters around thresholds and roaming, and you can do these things, and you have total control end to end of the device. If that's important to you, right? If you're in an environment where this just happens to work, right, and your applications can't take outages, right? So that's the benefit.
Gotcha.
So that'd be all, Dan.
All right. I think we're good on questions. I don't see anything else. Thanks, guys. This is great. I know this is another first here for Unplugged. I think we've had Ian in a truck before on Unplugged, but now we have
Virtual.
Yeah. Now we have a smaller scale RC truck that he was driving. He was driving in both trucks, but he wasn't in this one. But I love that demo. That was great. I just can't help but keep laughing.
And we were watching the truck afterwards. You started like, what were we talking about again?
I know. I want to drive the you can bring that to Vegas next week. Let's drive it.
It is coming with me. There's another reason we bought it. Yeah. We're doing the same demo.
Okay, great. Yeah, I'll find you. We can drive it. We could take it out for a spin. But thanks, Igor. Thanks, Ian. Great episode, and appreciate your time here. And so just a reminder here, we do have our upcoming schedule out there on the links section of our page on YouTube. If you go to youtube.com/@getunplugged, you'll see the first link there is our upcoming schedule of upcoming episodes. If you go out there while you're out on the YouTube page, click subscribe, click the bell. You'll be notified when we do go live with other great content. If you do want to reach out to us, you know how to connect to us. We were getting some messages and some emails. Thank you for reaching out to the show. You can email us at getunplugged@cisco.com. If you have any feedback, questions, you can also always reach out to your local account team with questions, feedback for the show, and they know how to get a hold of us. You can DM us on Twitter X at Unplugged80211 or on Threads at Unplugged Connectivity. So look forward to seeing you next time. Thanks again, guys. Great show. Until next time, stay connected and unplugged.